In order to prepare any type of solution, we need to know first several factors and follow several steps. Most of the solutions are prepared in the following order. Select the solute, which must be soluble, weigh it using appropriate instruments and equipment, dissolve the solute, and finally prepare the final volume. In order to ensure that our solution will be free of any type of contamination, we need to do is sterilize them. Sterilization is defined as the suppression of any kind of living organism in any object or material by using physical or chemical agents. The most common types of sterilization are the dry heat sterilization, the sterilization by Satur steam, by using radiation like X-ray, UV or others, or by using chemicals like alcohols, phenols, and others. The definition of a solution is any homogeneous mixing of the molecular level of two or more substances. Therefore, we can use the Tyndall effect to verify this. If we see particles, then our solution is not well prepared due to the fact that the real solutions don't show solid by decanting off or have the property of scattering light. Naturally, poorly prepared solutions can cause a great amount of consequences. Firstly, they will negatively affect every procedure in which they are used because many of these require very specific conditions or concentrations. When the solution is not entitled, it has the potential to cause confusion in the user if he doesn't know what he is using, which at the same time can cause other problems like, once again, cause non-desired effects in an experiment. If the solution is dangerous in any way, like being explosive or toxic, not knowing what it is can cause damage in the health of the user because the former will not know how to manipulate said solution and what it requires special measures.
To prepare 100 milliliters of the 3-hydrochloric acid solution, 12.1 grams of 3-base in order for it to be in a molar 1 concentration. The 3-base was dissolved in 80 milliliters of distilled water. The pH had to be adjusted to 8 and it started with a 11.15 value. So, a high concentrated solution of hydrochloric acid 5 molar was added while reading the changes in the pH as drops were mixed in a beaker being agitated with a magnetic stir. When the solution reached 8, the volume was measured in a graduated cylinder and it was approximately 98 milliliters. Water was added to get the 100 milliliters mark. The loading buffer was prepared by diluting the stock that was previously made in the laboratory. The 5 milliliters of loading buffer contained 1.5 milliliters of glycerol, 200 microliters of the stock solution, and the remaining 3.3 milliliters of distilled water. The STE solution was prepared by mixing 0.96 grams of sucrose with approximately 2 milliliters of water. When the sucrose was fully dissolved, 1600 microliters of 1 molar 3-hydrochloric acid was added and 1390 microliters of 0.43 molar EDTA. The volume was adjusted with distilled water up to 12 milliliters in the Falcon tube.
Several concentration units exist because they are useful for different purposes. Molarity is helpful to identify the amount of a substance present in a liquid solution. Molality is used to calculate colligative properties, such as the boiling point elevation and the freezing point depression. Normality is the amount of equivalence of reactive particle per liter of solution and is frequently used for acid-base titration. Parts per million is a unit to measure small levels, for example, pollutants in air or water. Percentile concentration is used to know the relative amount of a substance in a mixture. For example, ethanol 70% contains 7 parts of ethanol and 3 parts, the remaining 30%, of water. X times concentrated is used in stock solutions to determine the dilution factor to use in other solutions. To prepare solutions, you must consider the nature of the components, for example, when you mix glycerol, the solutions of acids prepared in an extraction hood, to adjust the pH, properly read volumetric instruments, avoid precipitation by mixing or heating, remove heat from the mixture of compounds, label the solutions, sterilize solutions without thermolavable substances, the presentation of the substance like hydration, and special procedures or suggestions. To properly elaborate solutions, one must understand how to calculate the amount of the compounds and the procedure every solution requires to be correctly finished.